Okay, hello everyone. Welcome to the September community call. This is the first one since July. In August, we took a bit of a break due to people's holidays and so on. So this time we've got quite a lot to talk about and to show because we're coming very close now to the 4.0 release of SingularityCE. That's on the calendar for September the 19th, so less than 2 weeks now. What I want to do in this meeting today is take a look at some of the things which are changed or new in CE4 that are upcoming, and particularly point out some of the non-OCI related changes first, which have had a little bit less coverage in the previous months. So please stop me at any time if I'm going too fast or there are any questions, just jump in and shout out. And as always, if there are any questions when you're watching this on YouTube offline, you're welcome to post in the discussions thread I have open here in the browser. So on GitHub, we now have a discussions thread open for each community call, and questions and comments and things are welcome on this too. Okay, let's hop over to the changelog here. What we can see at the top is that we're now on the second release candidate. This was put out a couple of days ago for the 4.0 release. And the major change between this and our first release candidate is that Omer did some work so that on certain systems where some tools which are required to create an OCI SIF image aren't available, the OCI mode in Singularity can fall back to extracting the container out on disk and running it from a temporary sandbox, much like it does in the traditional native mode if your system doesn't support user namespaces properly with unprivileged overlays and SIF mounting and so on. So what you see here then generally is that the second release candidate had a few changes. The first one went out last month, where we were having our kind of break from the community call, and we've seen relatively little sort of comment or bug reports there. We've had a couple of things mentioned, but it would be great if you could take a look at the release candidate notes, and if you've got any time to test anything which looks interesting to you, let us know on Slack or through GitHub or through GitHub discussions, anywhere that you can reach us if you find anything that doesn't quite work or you think could be improved in some way. We'd love to hear any feedback and all feedback before we make the stable release in a bit over a week's time. Okay, so if we look at this release candidate 1 notes here in the changelog, this is really going through all of the stuff that's in the upcoming 4.0 and isn't in 3.11. Lots of it, as I mentioned and we've talked about in the past, is related to the new OCI mode, which is about running containers and storing containers in a way which kind of retains some of the benefits of Singularity, like the single file SIF format, but makes it more compatible with OCI runtimes by using a low-level OCI runtime as the core, which kind of executes the container at a very low level. However, we now have a bunch of things below the OCI mode, which are other changes. Some things on the CLI, a couple of changes to behavior of the native runtime, and some new functionality. So what I'd like to do is switch over to a terminal and start talking about some of these things so that you're aware of what's going to change in 4.0. So one of the major things that will happen is that you'll notice if you use the Singularity remote command, it has been modified quite a lot to split things out. So if I use Singularity remote list here, what I'm used to in older versions of Singularity is potentially seeing not just details of the Sylabs cloud that I'm logged into, or a Singularity Enterprise installation, but also things related to key servers and OCI registries, which I might have logged into to pull containers, for example, from Docker Hub or Azure Container Registry, things like that. All of that sort of login functionality, everything for managing which key servers were used, that was all put in the remote command. And having spoken to a lot of users, I found this was quite confusing for people. So what we've done, and Omer, who's on the call, has mainly done, is pull out things into separate commands now. So whereas before Singularity Remote dealt with lots of stuff, now it only deals with endpoints, which are the Singularity Container Services or Sylabs Cloud, or if you have a Singularity Enterprise installation on site that you connect to, or you're using some other kind of third-party service or open source project, which implements the same protocols as these systems. The remote command no longer includes the functionality for managing key servers or OCI registries. So if we think about OCI registries first, we now have a Singularity registry command. And if I show the help for this, you'll see this is all about managing authentication to OCI and Docker registries. So this is where you will do a Singularity registry login and provide the URI of, say, Docker Hub, the Docker IO URI, and your username and token, in order that Singularity can then pull Docker images from private repositories and so on. So this is where the OCI stuff is now managed. And if I look at Singularity registry list, we'll see that I have, in fact, logged in previously to docker.io, which is Docker Hub, and my credentials are stored there. So this is the place I'm now going to manage logins to OCI registries. There was also a lot of stuff in the remote command related to key servers. And this has been moved out to a subcommand, Singularity Key Server. So if I show the help for this, this is where you can, if you wish, configure custom key servers that aren't related to the Singularity Container Services or Singularity Enterprise install that is configured through the remote command. Not many people really use this. This would be if on a site you were running your own key server and you wanted to keep your public keys kind of private. It is somewhat unusual because usually the public keys, you want to share them widely if you're signing containers. But of course, you could keep it private, or you could choose to use some other key server which is public out there. There are numerous ones. If I do a Singularity key server list here, I'm not set up with any custom key servers. So all it's going to show me now is that my key servers are associated with the things I have set up in Singularity Remote. So I've got the live Singularity Container Services or Sylabs Cloud key server. And there's also a staging remote I have set up, which you can see there. So that's the first thing to highlight. Hopefully the separation from the remote command into registry and key server makes it clearer what you're actually doing when you say login, because it was very overloaded in between the remotes, i.e. the Sylabs Cloud or Singularity Container Services, and OCI registries and so on. Any questions on that before I carry on? Okay, so the second kind of fairly big thing to point out. Might seem a little trivial, but it's a relatively large change in behavior, and it's something that we've pulled in from the Aptainer project who made this change. It's about mounting of the current working directory when you enter a container. So in old versions of Singularity, quite a long time ago, the current working directory at the time you ran a container was always bound into the container, and you always kind of entered that current working directory. Then later on in the Singularity 3 series, behavior changed so that the current working directory was only bound, was only kind of entered and bound in if there was a path existing in the container which matched that. And part of the reason for this was that you could have all sorts of mess occurring with symlinks on the host versus symlinks in the container, and things just not matching up. But over time, I think both the Aptainer project and ourselves have noted that people really want the current working directory and expect it to be mounted in all times. And the documentation has kind of inferred that it would be. So this kind of behavior has been brought back. So if I go into a directory on my host system called data test here, this directory is not in the container. But if I now choose to run a container, so this is Docker Alpine, which definitely doesn't contain the directory data test, and I let that pull the container and end up in there. If I use pwd, we can see I'm inside data test. If I use ls, we can see that I've got stuff there which is coming from my host. So that handling of the current working directory is occurring as more people expect compared to the later portion of the 3.11 series. So we felt that we're able to make this change now because we're going up a major version, but it is a behavior change. It's probably quite innocuous because if you are trying to work around the existing behavior by bind mounting things, it's likely to just continue working, but it is a change to the behavior that you will see when you enter a container. Okay, the other thing I'm going to thank the Aptainer project for is build templating. So lots of people have been asking for templates support in definition files, where if you have a definition file, some bit of the content of the definition file is not known when you're writing the definition file, but it's known at the time you build it. Maybe you want to be able to customize the version of a piece of software you install without having to completely rewrite your definition file or something similar to that. So the Aptainer project sort of did some work on this. We pulled it in. Omer did a lot of rewriting behind the scenes on how it works under the hood. But what we've ended up with is a way where I can now go ahead and create a definition file. I'm going to try and jump over on my host machine here, and hopefully I will have definition file now pasted in, where I've got some brackets here. Okay, I've got double curly braces and an identifier here called some text. And this is the format of the templating. If you have these double braces, then what you've got inside here, this identifier, is the name of a build argument. So when we build the container, we'll be able to replace this build argument with some real value. I'm going to jump across again, and I'm going to grab my build command, and I'll set it going a second here. Oh, sorry, I named the definition file wrong there. what we have here, we got the build command, and you'll see this --build arg, and you'll see that we're setting some text, which was the identifier we had in our definition file, to the value hello world. And the build's going to go ahead now. And if I run the container, which has come out of it, what we'll find is that it echoes hello world because that template argument there was replaced during the build. So that's another thing that is available and is going to be very useful to a lot of people who've been asking for this sort of functionality for quite some time. Any questions on this so far? Okay, let's carry on, and there's a couple more things to show before we get to the OCI mode stuff and talk about that again. What I want to do here is demonstrate some expanded support for architectures or platforms, as they're called, when you use another OCI runtime. So for a long time, Singularity has been able to pull images from the library with a flag, arch, and then if you pull, let's say, Ubuntu, and you want it for ARM64, you can do that. I'm on an Intel machine here, or an AMD machine, but I can actually go and ask Singularity to get the ARM64 container. And if on my host I have QEMU static configured with something called bin format MISC, then I can actually run that container on my AMD host, even though it is an ARM64 container. I can drop into it and I can say uname -m, and we see we're running an ARM64 container emulated using QEMU. So this has been possible for quite a long time now. There's a blog post on this on the Sylabs site. If you want to go and search for bin format MISC, you'll find a blog post talking about how to get this set up on the system so it works. What's new is that we've expanded the ability to kind of handle these foreign, if you like, foreign architecture images to OCI images from Docker Hub and things like that. You can now use the flag called --platform to pull down an image from a Docker or OCI source. So here it's the Alpine Docker Hub image. And you can ask for different variants of the image in the way that they're named if you use Docker or another OCI tool. So the platform for OCI images consists of an OS, and Singularity only supports Linux. We don't run natively on Windows or anything. Second portion is the architecture. So here ARM actually means 32-bit ARM. And then the final bit, which is optional after the second slash, this V7 is the variant of the architecture. So ARM systems, you have lots of different versions of ARM chips. You have old ones which don't have any hardware floating point. You have newer ones which have hardware floating point, and so on. So here we're going to ask for a 32-bit ARM image, which is a V7 image. And we're going to ask Singularity to pull this down to a CIF file, and it will go ahead and do that, fetching the correct image from Docker Hub. And if we did this multiple times now, it will be cached properly by architecture. In the past, when you're dealing with Docker images, there have been problems caching images of where you have the same image of different architectures, because maybe your home directory is shared between ARM and Intel systems. The caching mechanism for OCI stuff has been rewritten now, so that doesn't occur. If anyone's interested, technically, what we do now is we compute the hash for our cached image, based on following through to the image itself when you have a multi-architecture repository, when before we were basing the hash on the image manifest, which is the same for all of the architectures, and that's why things were getting mixed up. But there we go. I can pull my 32-bit ARM image from Docker Hub using this platform option, and then I can certainly go ahead and run Alpine ARM v7. And if I do uname -m in here, we see we're on a ARM v7L architecture. That's what the Linux kernel is calling it. And again, this is running in emulated form using QEMU static and that bin format MISC stuff. The shortcut to not type out all this Linux ARM v7 stuff or Linux/ARM64 is to use the arch flag like the library does, and we can specify just the architecture, which will be the middle bit of the platform. So if I say arch ARM64, that's kind of inferring then Linux/ARM64/v8, which is what we have for ARM64 images in Docker Hub. So I can go ahead and do that to get an ARM64 image. And if I ran that one in and did the uname m stuff again, it would tell me it was an AArch64 image, as that's what the kernel calls ARM64. Any questions on this portion? Okay. What I want to move on to now is a recap of the OCI mode, which is the kind of the bulk of Singularity 4.0 that we've been working on. And really, OCI mode is, like I mentioned at the beginning, all about improving compatibility with OCI containers and other OCI runtimes by recognizing that Singularity's own native runtime was written for the constraints of HPC and older Linux distributions several years ago now. And things really have moved on. People are more likely to be using Docker or Podman and things in building images, OCI images on their laptop, on their desktop, or even on an HPC system or with some kind of CI, and then deploying those images, running them on a HPC system, often with Singularity, because it still has very strong benefits with the image format and so on. But we're seeing lots of people who they really just want to take OCI images they built elsewhere or that someone else has built and ensure that they run as expected on the HPC system, with really no differences. Okay, so even some little things, the way that Singularity handles some mounts, or the fact that it doesn't allow a container to run under the user account that the Docker file specifies. They can get in the way and they can hang up people, especially if you're kind of following documentation that assumes you're running on Docker or Podman or similar. So the OCI mode that we have now is built around still the CIF format, but we are calling the OCI variant of CIF OCI CIF. And we'll start by taking a look at an OCI CIF image and what that's about. I'm going to do a Singularity pull of an image from Docker Hub, but I am going to put on the OCI flag to turn on OCI mode when I do the pull. What's going to happen is Singularity is going to go out and it's going to fetch the configuration and the layers for that OCI container at Docker Hub. And then it's going to convert the image to OCI CIF format, rather than converting it to what we'll now call a native CIF, which is the format which runs under the native runtime rather than OCI mode. We can see a little bit of what the difference between an OCI CIF and a native CIF is by doing a CIF list and looking at the file. If I look here now, I'll see that the OCI CIF consists of 3 OCI blobs and an OCI root index. What we actually have here is, first of all, the root file system. So Singularity has gone and taken the layers and squashed them down to a single layer, which it has made squashfs, but it's representing it as an OCI blob, which is annotated as a layer. Then the second and third portions, we have the image manifest and the image config, which have been taken straight from the registry. There's been a little history appended, so you know there's been this conversion to OCI CIF, and then they've been inserted into the file here. So the metadata about the image, the command it's going to run, the environment and so on, that's all in the image as this OCI blob, which is an OCI image config. And the more general description of what makes up the image, the layers and so on, is an OCI image manifest. If I look in my directory here and do a CIF list of something that's a traditional Singularity image, let me clear that up. Then what we'll see is that it has a bunch of stuff which is not OCI at all. It's Singularity specific. So I've got a definition file. I've got JSON generic, and this is Singularity's own metadata. I then have a file system, a squashfs file system of a certain architecture. And this is the container rootfs, into which Singularity has chucked some stuff. Right, so it's put in there some Singularity specific stuff. There's a .singularity_d directory in there, which is holding scripts for starting up the container. The OCI CIF doesn't have any of this Singularity specific stuff. It really is representing the container as an OCI image, which just happens to be encapsulated into a CIF file, so it's a single file. Okay. If we want to run then the OCI image, it's just a case of enabling OCI mode again and giving it the path to the image, and I drop into the container. There are a few things to note that are different to the native mode, the non-OCI mode. First of all, if I take a look around, my home directory is empty. Okay, it's not bind mounting my home directory in from the host. If I want to create a file somewhere, I can go ahead and do that. So by default, the container is writable. I can write new files into the container, and they'll be there until it exits. Also, if I do env, we'll see that the environment in the container is very slim. The environment of the host hasn't passed into the container. Now, if you've used Singularity a lot and you've tried to run many OCI images, things from Docker Hub, you might have had cause to turn on a flag called --compat when you're doing your Singularity run. The OCI mode default behavior is very similar to if you run Singularity in non-OCI mode with the --compat flag. And the reason for this is that we're trying to be compatible with other OCI runtimes. By default, we're trying to present the environment that containers expect. People write their containers and publish them on Docker Hub, expecting that they'll be run with Docker or Podman, so that if you have a Python package installed in there, and Singularity is binding in your home directory, you can end up with issues like mixing of Python packages from your home directory versus what's in the container that you don't have on Docker. So that's the reason why we're targeting this sort of like compat of the native runtime in OCI mode, so that we behave like Docker. And if you're following instructions for running a container from Docker Hub, it's far more likely it's going to work as expected in OCI mode, because by default it is really replicating much more closely what you would get with Docker. Another kind of way we can show this is looking at running a container where the container has a Docker file which specifies the container should run as a specific user which has been created in the container. I've got one that I can run, which is up in Docker Hub at our repository. It's Sylabs.io Docker user. If I try and run this container, the container is just going to show me what user I'm running as in the container. So down here at the bottom, once the container has been created and executed, we see that inside the container, things were running as dtredge Sylabs as the UID in the group, which, this is my user and group outside of my host. It's not what the container is requesting. The container has a user statement in the Docker file, but Singularity just isn't honoring it. So perhaps some software and so on won't work correctly. If I switch on OCI mode and do the same thing, it's going to go out and get the container into the OCI CIF format this time. And when it runs, we'll see that instead of giving my host user as the output, it's showing that it's running as test user with the UID and GID of 2000, which is what the Docker file is asking for. Okay, so this is another example of how OCI mode, the aim of it is to support running OCI containers as they were intended, so that you have fewer problems with compatibility. Any questions up until now? I've been talking quite a lot and everyone's been quiet, so please feel free to stick something in the chat or raise your hand or just shout out if you want to. Okay, it's a quiet one, so I'll carry on. The converse of following this Docker behavior is the opposite of it is that sometimes people want things to behave like Singularity does. It's very convenient for the home directory to be mounted in. It's very convenient sometimes that I've set a lot of environment up on my host and I want it to be available inside the container. So although the OCI mode does default to the kind of quite clean environment and so on that people are getting with Docker and compatible runtimes, we can say no compat. And this is going to make the OCI mode run more like Singularity. And this is a little bit of a kind of bug, if you like, right now. You'll see that the prompt hasn't changed to the familiar Singularity prompt, but I'm in the container now. And my current working directory is mounted. If I look at the mount table, I'll see that my home directory and things are in there. If I look at env, it's brought in the stuff from the host and so on. If I try and create a file in the container, it will tell me it's read-only because that's the default of the Singularity native runtime. Okay, so there we go. If you want to use OCI mode, but you want to go back to Singularity's kind of traditional default behavior, then no compat gets you back to that. Similarly, people will want to probably use OCI mode, but run a non-OCI CIF container, run something that they've created before. So I'm going to go, and now I'm going to just get a traditional Singularity container, non-OCI mode one, by pulling from Docker Hub, and this is building it into the traditional sort of older CIF format. Off it goes. See how quick my internet is today.
DT, I think you might still be in the container that you demonstrated with the no compat.
I don't think so. I think I exited. We'll see. This won't work if I am. So it's built it there. And now if I want to run this container with OCI mode, but it's kind of a traditional format container, there we go. It's going to warn me, but it's going to put me in the container. Again, the defaults of OCI mode are the clean environment and so on. But if I want to, then I can ask for no compat to get the similar kind of behavior with the end going into the container and so on. So there we go. I'll drop out of the container now, and I think we're good. Any questions at all about this stuff? Anything anyone wants to raise or so on? Dave, I see you're on the call. Any thoughts or questions? Okay, it's definitely a quiet week, but
I was gonna say, I think you pretty much answered my question. Was what are the differences from Podman? I guess there's the CIF format, and then the fact that you can go to no compat, right? And what else is there? Like any significant differences from Podman when you're in the OCI mode?
Yeah, so the no compat, so you can go to the kind of traditional Singularity behavior. There's the ability to use OCI CIF, which is the single image format, and kind of preserve the image as OCI. That's going to be expanded in future too. So although right now we always squash down to a single squashfs layer in the OCI CIF, the idea in future is to be able to handle multi-layers and move towards more being able to go into and out of OCI CIF while maintaining the content properly, so doing stuff in a lossless manner. The other bit is compared to Podman, this is really a more simple structure. It's built around the interactive usage model. At present, the OCI mode doesn't support instances, which is what Singularity calls background containers. It's purely around interactive use, so the run, exec, and shell, which is how most people are using Singularity in a terminal or from a batch job. And because we are not trying to yet support the entire OCI container lifecycle with detached containers and things, the flow that we use is a lot simpler. So Podman has to spawn quite a lot of things. If you spawn a Podman container, you'll see that there's kind of a helper spun up, which sits behind the scenes, because there's a lot of setup and tear down and stuff to be done, a lot of tracking of containers which can run in the background, a lot of complicated stuff. This is a much kind of simpler flow, which is targeting the way in which people have used Singularity traditionally in the non-OCI mode, and trying to bring the OCI compatibility to that.
Another question I have is, what was the reasoning behind going to a new major version number instead of another minor version?
Right, so we are, well, since the CE fork, we've had a wish to adopt semantic versioning, so that a breaking change, a significant breaking change to the command line or the way in which things are operating that will break someone's workflow potentially is going to be a new major version. We wanted to do this, but we've been waiting for a good point to do it. And this is an obvious good point. We've got some changes in here which change the CLI. We've changed the remote command to split out registry and things. The behavior of mounting or not mounting the current working directory, that's a behavior change. And then also this OCI CIF format, right? You can't use OCI CIF with the 3.11 version of Singularity. You need the 4.0 version or newer to handle the OCI CIF. So going up to the major version gets us on the kind of Semver pattern, but also makes it clear that the OCI CIF is a new format, right? It's CIF, but the pieces in the CIF are not understood by older versions of Singularity. So going up to 4 helps make that clearer, that this is a bit of a jump.
Although it is upward compatible.
Correct, yeah. The like I say, the traditional sort of native runtime is still there. It's still the default. OCI mode is something you turn on by a flag, or you can make it the default through singularity.conf. The functionality, other than the kind of CLI changes and some runtime stuff we talked about of Singularity with its native runtime, hasn't changed. We're not breaking workflows of people who've been using Singularity and CIF containers, but we are adding something that's significant and new, and yeah, these images which cannot be run by older versions.
If I could jump in with something small, this is related to Dave's second to last question about ways in which the OCI mode differs from Podman. This might be less significant depending on one's usage patterns, but I think it's worth mentioning. It's important to keep in mind sort of separately the OCI CIF format and pull commands with the OCI flag versus using the OCI flag for the so-called action command. So that is run, exec, and shell. So in particular, the OCI runtime allows you to still still run containers that you've built in other fashions, not pulled from OCI registries necessarily. And there again, you're then not sort of constrained to Podman's ways of constructing an OCI container. You may build your container through other means that Singularity makes available, and still run it in OCI mode.
Yeah, I should mention here that also the OCI mode right now, it's concerned with running containers. So in 4.0, we're concerned with OCI mode for running existing containers. You can certainly Singularity build containers from definition files. These are then not OCI CIF, but they're traditional CIF containers that can be run by 3.x versions of Singularity or 4.x, and you can use those. But yeah, I should have made that clear that the OCI mode in 4.0 is about running. Building containers in OCI mode is a topic for future minor versions of 4. But as Omar says, you're not really limited to a particular tool for building your containers. You can build OCI containers in any manner of ways and then run them with this new OCI mode. Okay, any more questions or any comments on this? Hopefully I've given a relatively decent overview of things to kind of refresh people's minds of some of the stuff we've talked about in previous meetings. If not, I just want to, before we finish up then, share the roadmap thread on the GitHub discussions here, which is titled SingularityCE 4.1. Okay, so We're going to release 4.0 soon. We're thinking about 4.1 and what should be in it. You'll note, yeah, that we haven't really moved anything up into the planned features. So feedback from people on what's important, what you want to see here is very welcome at this time. You can drop it on the thread here. You can post in Slack or something, or just make us aware however you wish, what you're interested in and what you'd like to see in future versions. Having said that, the things that are under consideration include improvements to the OCI mode. So I've talked about multi-layer OCI SIF images that can let you move into and out of OCI SIF from registries and so on in a less lossy manner. There's consideration of instances for OCI mode or background container support in some manner, whether that is emulating the instances which exist in Singularity now, or whether it is closer to the OCI container lifecycle. That's not necessarily decided at this point. Some of the other holes in OCI mode right now are that you can't use an overlay that's embedded in a SIF file. There are some questions about how to represent an overlay in an OCI SIF file because we want OCI SIF to be able to be pushed up to registries as an OCI image rather than a single file. So is an overlay some kind of layer with a special annotation or similar? So these are the things we're going to explore and resolve for 4.1. The SCIF or SciF, the scientific file system where you can define multiple apps in a container and run a specific app, that's a standard which is not specific to any container technology. It's most commonly used in Singularity, but there's no reason why you can't use that in OCI containers, Docker containers. So really support for that could be added to OCI mode. And then there are some things which are a little bit longer standing consideration. So for people who are definitely sticking with the native mode, the traditional mode of Singularity, and don't want to move to OCI mode yet, we are considering more use of fuse mounts instead of kernel mounts in native mode. We have some ability to use SIF to mount a fuse to mount a SIF and run it. But this is really around trying to support different security models. We have some people who definitely don't want to turn on unprivileged user namespaces. So certain modes of operation aren't available to them, like the OCI mode and fake root with UID mappings and so on. But we can perhaps bring them kind of like pockets which are used in those other modes back into the set UID approach. So that's something that's going to be explored. It's probably of most relevance to people who are stuck on older systems such as SLES 12, where you can't do fuse in unprivileged user namespaces because of the age of the kernel. But people might want to use fuse instead of a kernel mount. Down the list, we go to things which have been around longer. Build from Dockerfile has been discussed a lot. So obviously, I've mentioned OCI mode to date is about running containers. Thinking about building containers is obviously something for the 4.x updates, which will come. And then there's some other things about security profiles and InfiniBand handling and so on, which we have kind of had out for a long time, but we haven't had a great deal of input in them or exactly what people would want to see. So if these things are ones which interest you, kind of let us know what what you'd like them to do, and then we can start thinking about the scope and where they might fit in the roadmap. All right, I guess I've talked loads this time around, so I'll open the floor to any other discussions or any questions or comments at all. Anything anyone wants to ask or mention related to Singularity or anything else in the world. All right, well, we'll call it for now then. You can have 8 minutes back, and look forward to seeing people in October, when obviously we'll be then starting to do some of the development work for the next version, and we should have some meaty discussions about deciding some of the things that we've talked about there with relation to the roadmap. Thanks for coming, everyone, and we'll post this to YouTube as usual.